All right, and it's Organic Friday, and we're here to talk about ketones, which are an important class of organic molecules. Let's jump right in and look at the formula. So what we have in a ketone is we have a carbon-containing chain, and then it's got a carbonyl group right in the middle of the chain. All right, so R is one of the things. It's got to contain a carbon. The other side of the carbon also has a carbon-containing group. All right, these may be the same group. We'd call this a symmetric carbon or an asymmetric carbon, depending on the scenario. Okay, so let's go on. All right, here's just some examples. There are a lot of ketones that do occur naturally. You guys are familiar with acetone, but fructose is a ketone, right? Cyclohexanone is a ketone. I like this one, butane 2,3-dione. It's actually got two ketones, right? It's a diketone. And this was interesting because this molecule has a buttery flavor, and it's been used to flavor margarine, but it also appears to be toxic. So the factory workers who work in the plants where they're making this and using it to flavor the popcorn are coming down with this really horrible disease caused by too much exposure to the diacetyl. So it's being considered as possibly being banned as a food additive at this point, because in very high concentrations it does cause a lung disease that's incurable. But these are quite common things. Ketones, all right, a lot of biological processes will make ketones as part of the reaction. All right. An analogy, all right, to help you remember this. A former student came up with this analogy years ago. When you build an arch, you may have a keystone in the arch, right, that holds the arch together, makes everything work properly, but the keystone has to be in the middle of the arch. So hopefully that will help you remember how ketones and aldehydes are different. All right, because in aldehydes, where was that carbonyl group? At the end of the chain. But in a ketone, it's in the middle of the carbon chain. All right. And so that's really what we have to do. All right. All right. Just as an aside, really, because we are not in this course expected to really learn a lot about the reactions of ketones, you can make them by oxidizing secondary alcohols. Right? So an alcohol with a carbon attached to the OH group has two other carbon-containing groups. If you oxidize this, say with permanganate ion, all right, you can form a ketone. And ketones do a lot of different kinds of organic reactions, but that's beyond the scope of what we need to do for AP. All right. One thing we do need to know, though, is how to name ketones. All right. You guys already know the most common ketone, which is acetone. All right. And you might not be able to draw the structure off the top of your head, but you've heard of it before. All right, so that kind of gives a clue as to the naming for ketones. All right, which is on the next slide. All right, so what you do to name the ketone is you find the name of the parent alkane chain, that longest continuous chain. All right, you drop the E from the alkane name, and you add the ending "-one". It's not one here, it's "-one". All right. And then if it's anything larger than 3 carbon atoms, you need to give a number giving you the location of that carbonyl group. So for example, if we draw the simplest ketone, which is acetone, all right, like that's its common name, but its formal name is a little bit different. How many carbons in the longest chain? 3. What's the name of a alkane with 3 carbons? 3 carbons. Say it again, Eric. Propane. So this isn't going to be propane. This is propanone is the formal name. All right. And we don't need a number for propanone because the only place we could have the carbonyl and call it a ketone is on the middle carbon. But anything with more than 3 carbons, we're going to need a number. All right, so let's do some practice with this. All right, so let's look at this top molecule. Longest continuous chain. How many carbons?
5, 6.
1, 2, 3, 4, 5, 6. 6 carbons. All right. What's the alkane name? hexane. So the ketone name would be,
3-hexone.
say that again, Nick?
3-hexone.
3-hexanone.
Oh,
You're so close. All right. 3-hexanone. All right. Because we could number it in two ways. If we number from the left, it's on carbon 3. If we were to number from the right, it would have been on carbon 4. We always want to go with the lower number. All right. All right, let's look at the second one. How many carbons in the chain?
4.
4. All right. And what position is the carbonyl on? Second position. So the name of this is?
2.
Butanone, exactly. All right. And let's just do a little bit more practice. Can you guys draw 6-chloro-2-octanone? All right, so how many carbons in my longest chain? 8. All right, so 1, 2, 3, 4, 5, 6, 7, 8. All right, what's on carbon 2?
Double bonded oxygen.
All right, and what's on carbon 6?
The chloride.
The chlorine. All right, so you have something like this drawn. You might have drawn it as all the carbons themselves instead of drawing the dashes. That's fine too. I should mention that the nomenclature system, something else has been introduced. So sometimes you'll actually see this written as octane 2-one, which is really just, that's actually the new standard for how these things are supposed to be written. So the number goes in the name just before the suffix showing the functional group. I don't like it, so I don't tend to do it. But if that is actually the current standard for the naming. All right, we'll pick this up another time.